This is the hints video for problem number 3. So let's get right on this. Here's a similar problem, all right, that you'll be able to use to solve the one there, and then you'll have a problem like this probably in the review questions also, which is in the activity that's following. So let's see here. What we have is we have a river otter eats 10,000 joules of food energy. The river otter uses 15% of the food energy for biomass, and the rest of the metabolic processes and waste. Use this information. All right, so what we need is 15% of this number right here. So he eats this much and only uses 15% of the food energy for the new biomass. So 15% of that is being used for new biomass, and the rest for metabolic processes. So we have our 10,000. So for A, we have our 10,000 joules, and we're going to multiply that by 15%. So that 15% we need to change. Right, so we're not going to use it, we can't multiply it by that unless you have a calculator that does that. We have to change it from percent into a decimal. Okay, so we take our 0.15, and what we're going to do is we take our hidden decimal point and we're going to move it over to the left twice. And that's the same thing as getting rid of the percent sign, which is when you make a percent, you multiply by 100. When you get rid of the percent, you divide by 100. So I'm moving the place over 2 places. So that's going to mean that we are taking that and multiplying it by 0.15. So when we go ahead and do that, and you plug that into your calculator, all right, that's going to be joules. So the amount of joules that is possible then is 1,500. All right, so 1,500 joules there. Okay, so the next one, heat and excreted as waste. So that is going to be the rest of this. So that's going to be 85% of this. So we have our 10,000, and we're taking the rest of it, 0.85% or 85%. So that would be the rest. Again, if 15% were used for food energy, then the rest of that energy would be used for waste, so that'd be 85%. All right, so again, we're going to convert that over, so we have our 8.5. An easy way to remember how many zeros are moving it is there are 2 zeros in the percent sign. So we're moving it 2 zeros, and again we're dividing by 100, so it's going to move it over 2, so it's going to turn into 0.85. You're going to be left with 8500. Now, some of you have already probably noticed that 8,500 and 1,500 equals to 10,000 because energy is conserved. So some energy is used, some of it's wasted, but adding them together will equal that. So an easy way to do the problem would be also, hey, if this is what I used, then that means all I have to do is subtract, and I can get the same answer. So I could have subtracted 1,500, and that would have given me 8,500. So that is another way, an easy way to do it when you get this problem again. So what percentage of the food energy was converted to heat and excreted as waste? And again, we already know that that was 85% because we take our 100%. We knew that there was 100% of the energy, and we subtracted from that 15% of it was used for biomass, so I was going to leave 85% left. All right, so what percentage of the food was converted to heat energy as waste? 85% of the energy was converted to heat energy and waste. And I have this wrong. I should have percent here and percent there, not joules. All right, so that solves this problem. Again, the major concept of this, let's go over that. We have this amount of energy, and only a little bit of it is actually going to be used for biomass and used to produce. The rest of it is going to be stuff that's going to be lost as heat to the environment, or it's going to be waste that we cannot absorb. So most of the energy that we get is lost, and only a little bit of it goes into the next level as energy for new biomass or for new mass in the next generation or in the next trophic level. If you have any additional questions, please ask your science teacher.